Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss Davisson-Germer experiment. Let's begin. In the year 1927, two scientists, Davisson and Germer, experimentally confirms the de Broglie hypothesis as the wave nature of particle. According to de Broglie hypothesis, each moving particle is associated with a wave, which is called de Broglie wave or matter wave, and the wavelength of such type of wave is given by lambda is equal to Planck's constant divided by its momentum, which confirms the wave nature of particle. That was confirmed by experimentally Davisson and Germer. Let us discuss what be the experimental arrangement and how that experiment confirms the de Broglie hypothesis. Experimental arrangement. The apparatus consists of an electron gun G, where the electrons are produced and obtained a fine electronic beam which of known velocity. This is the experimental arrangement. In that of evacuated chamber, evacuated tube, it is a tungsten filament F that is connected to a low tension battery. Again, two nodes which connected to accelerating battery. It's a electron gun. When that filament is heated, thermionic emission phenomenon takes place. So electrons are ejected from that of filament and it passes through these two nodes with a collimated beam, and electrons are ejected through this, and this portion we call electron gun G. Electrons are ejected in the form of bullets in that of gun, and this electronic beam, we know the velocity of such electronic beam. The electron gun consists of a tungsten filament F heated to become dull red, so that electrons are emitted due to thermionic emission. Tungsten filament F, which is called cathode gun, it is heated thermionically and electrons are ejected from this. Now, the electrons are accelerated in the electric field of known potential difference. Here the electrons are accelerated due to that of electric field. This is the accelerating potential, and we accelerate these electrons by using that accelerating battery, and the potential is known to us of this electron as ejected in that section. After this, the electrons are collimated by suitable sides to obtain a fine beam. Then these accelerated electrons are collimated and ejected through this. The beam of electrons are allowed to fall normally on a large single crystal of nickel, which is known as the target. that one is a nickel crystal, and the ejected electrons now incident on that of nickel crystal normally. The electrons are scattered from the crystal in different directions. Electrons incident normally on that of nickel crystal. So, due to the collision of atom of that nickel crystal to that of electrons, so the electrons are scattered in different directions. The angular distribution of these scattered electrons is measured by an electron detector. Here an electron detector is used, and that electron detector measure what be the angular distribution of such electrons those are scattered from that of nickel crystal. The detector can move in a circular graduated scale S between the angle 29 degree to 90 degree to receive the reflected electrons. Electrons incident and these electrons scattered, which is called the scattered beam of electrons, and that electron detector used to detect such electron distribution, and which is circular graduated scale, means the nickel crystal as well as electron detector in such a way that they move with respect to each other. And that rotation within the range of 29 degree to 90 degree. With that of nickel crystal, let detector, nickel crystal to detector move like this. The detector is connected to a sensitive galvanometer which records the current. Again, with that of electron detector, here we use a galvanometer. This is sensitive galvanometer. That records the current. Next, come to the working part. Working. We have to plot the graph between the variation of intensity of scattered electron and scattering angle for different oscillating voltage, that voltage range from 44 volt to 68 volt. Here the scattering angle, as we call the incident beam, the intensity of such incident electrons are calculated as this intensity is the function of the scattering angle. What be the scattering angle, that depend what should be the intensity here. Therefore, we plot the graph incident beam to that of known potential, and this is a potential range of 40 volt to 60 volt. What we observed? It is observed that below 44 volt the current is smooth, at 40 volt simple the current is smooth. A bump begins to appear in the current at 44 volt. At 44 volt, now the bump begins. This bump increases with increase of accelerating voltage and becomes maximum at 44 volt, and at that of situation the scattering angle is 50 degree. Then increasing that potential at 48 volt, bump again increases at 44 volt, bump increases, and after that 44 volt again that bump decreases, and here is the potential which is 54 volt at which the bump is maximum. Above 54 volt the bump decreases with increasing potential, increasing the potential, and almost vanishes about 68 volt. Thus electrons with kinetic energy equal to 54 electrovolt were strongly scattered at an angle phi is equal to 50 degree. On plotting that graph between that potential difference to that of incident beam, we obtain at that 54 volt potential the scattering angle is 50 degree, and we see the maximum incident beam. By using that condition we can mathematically calculate if the maximum incident beam means we obtain maxima here. Let we come to Bragg's law. When an X-ray is incident on a crystal and it is diffracted, so the wavelength of such X-ray is calculated by Bragg's law. Here as we choose the nickel crystal, this is the atom of such nickel crystal, this is the plane, when X-rays is incident on that of a plane, let me choose that with the normal, X-ray is incident here, then it is scattered. Again here we obtain the diffraction pattern. For maximum diffracted pattern, for maxima, the path difference in between these two must be integral multiple of that wavelength. So the path difference is calculated, normal drawn here, normal drawn there, that distance be d, that is atomic spacing. This is the atomic spacing. For nickel crystal, that d is equal to 0.91 angstrom. Let that angle be theta. This is the angle of scattering. This is the angle of scattering. path difference, that length as d sin theta, this as d theta, so that length d sin theta, again that portion d sin theta, so the path difference is 2d sin theta. From Bragg's law, by taking X-ray are diffracted, then for principal maxima two d sin theta is equal to n lambda. Here n is equal to 1 for principal maxima. So 2 in place of d, 0.91 sin. At that situation, what will be the angle? The angle, look that situation. Here the scattering angle is phi is equal to 50 degree. From that of graph we conclude at that potential the scattering angle is 50 degree. This is the scattering angle which is phi. This is the scattering angle phi, that is 50 degree here. So the angle, this one as theta, sorry, as I before predict that not equal to theta, this one as theta, 50 degree, 50 degree. So theta will be 65 degree, as all these angles are 180 degree, 50 50 100, then sorry, this is the scattering angle 50 degree. This is the angle of scattering, incident, scattered, this is 50 degree. Then another two angle 130. So one of this angle theta is equal to 65 degree. So sin 65 degree is equal to n stands for 1 lambda. Therefore lambda is equal to, as we solve it, we obtain 1.65 angstrom. Equation number 1. Here we consider X-ray as incident. X-ray, we taken it as waveform, and by using Bragg's law for principal maximum condition, we showcase what be the wavelength of such X-ray. According to de Broglie hypothesis, according to de Broglie hypothesis, wavelength associated with an electron is given by, electron is a particle the wavelength associated with that electron lambda is equal to Planck's constant divided by its momentum p, whereas h divided by momentum mass into velocity. As we know, kinetic energy of electron is equal to E v. For kinetic energy, half mv square is the electronic charge into potential. We have to take in what to be the value of mv in terms of electrovolt, that is ev. Therefore, mv square is equal to 2 ev. Let m is multiplied on both sides. M square v square is equal to 2 m ev, or mv is equal to 2 m ev under root. Therefore, H divided by 2 m ev under root. So, lambda is equal to the value of Planck's constant 6.62 10 to the power minus 34 divided by 2, mass of an electron 9.1 10 to the power minus 31, charge of an electron 1.6 into 10 to the power minus 19 coulomb, potential V is equal to 54 under root, and we solve that equation, and finally we obtain the wavelength in terms of angstrom as 1.66 angstrom, which is almost same as before we predict for that of X-ray diffraction. As we taking X-ray as wave, and that wavelength is that one, and again by using de Broglie's hypothesis, and the wavelength associated with an electron is same, so it confirms that electron is a wave. Thus, from equation 1 and 2, the de Broglie wavelength of an electron and wavelength found by Davisson and Germer experiment are in close agreement with each other. Thus, we conclude that wave nature of electrons are conformed and which is in accordance with de Broglie hypothesis, and is in accordance with de Broglie hypothesis. The wave nature of electrons are conformed, and it is accordance with that of de Broglie hypothesis. Are the result obtained here? is same that of result obtained there. So, here with the help of this video lecture we understand the concept of Davisson-Germer experiment, which confirms de Broglie hypothesis as wave nature of particle, experimental arrangement, working. From that of graph we showcase at this potential we obtain the maximum intensity at a scattering angle of 50 degree. By taking Bragg's law for X-ray diffraction, the wavelength is calculated. By using de Broglie hypothesis, the wavelength associated with an electron is same as evaluated before. From this two we conclude that the wave nature of electrons are confirmed, and which is nothing but de Broglie hypothesis. So, with this useful and informative notes, let me wind up the session. Thank you.